Thank you so much, Laura and Dave, for inviting me. And it's a real pleasure to be here. And I was telling the co-chairs earlier that it's a really nice ploy on their part that I'm chairing the next session. So this session will definitely end on time. Hopefully, the speakers for the next session are also in the room. I've met at least, I think, 2 of them. Please meet me right after my talk at the podium. So I wanted to talk about something I'm calling smart programmable networks. Doesn't mean that programmable networks are dumb at this point. But I think that there's a lot that we haven't quite finished with the SDN vision. And I'm going to touch upon a few of those topics. So what's the promise of programmable networks? So when we started, almost 10 years ago, at least the wave of SDN that we are in currently, the goal was to make it possible to innovate in the network space very fast. So at the speed of software, if you will, have modularity of features and programs to the extent possible. And really, one of the big battles was that device-by-device configuration is slow, it's hard, and it's really possible to make errors. And so it was really difficult to avoid sort of errors that would bring the network down very easily. And so can you sort of have an end-to-end programmatic control of network devices? That was sort of the next thrust. And then finally, sort of, can we simplify the operation of networks, which had been increasing in complexity, and to the extent that we can automate them? And we've come a long way. I think in the last 10 years, I think we should all pat ourselves on the back that really there have been fantastic innovations and changes. And we think about networks in a completely different way today than we did several years ago. So all that's great. But sometimes I feel, I feel exactly what this quote actually says. So I haven't read the book, but I feel there's plenty to be done. We're not quite there yet. And so the question is, why aren't we there yet? What are the hard problems? And how do we work collaboratively with other communities to be able to get to the vision of SDN the way it was thought? And so I've tried to classify SDN 1, 2, 3, and don't be too concerned if the definition, your definition of SDN2 and SDN3 and so on don't match mine. But roughly, this is where I think sort of the work on SDN started with the separation of control and data planes. Controller-based networking, there was a lot of emphasis on mechanics, like getting the open flow protocol to work, and what features should it have, and how would it be implemented on real switches, and so on. And a lot of the early work was designed around what applications could you build that gave you that end-to-end programmatic control, and things like quality of service, things like network-wide energy automation and virtualization. So these were sort of the applications, and mostly we were looking at enterprise networks and data center networks to see what simplification one could bring to that world. Then soon enough, we realized that the original sort of set of goals, and this is very natural, this is not to sort of blame the community in any way, but one of the thoughts that came about is, oh, by the way, we haven't really thought about middle boxes, for example. And middle boxes are very essential parts of networks that are deployed today, and they tend to have less programmatic control. And so a lot of the work around the next wave was around how do you handle middle boxes, how do you handle hybrid environments, because not everything was going to be programmatic on day one. And then there was a lot of focus on how do we verify networks in an end-to-end manner? How do we write programs in a systematic way that achieve the goals of network sort of end-to-end network programming? And so there was all this work around network programming languages, which is still ongoing. And really sort of the next phase of this focused on service provider networks and looking at the public cloud, for example. Now, the third phase of this, which I think we're already in, we're now looking at sort of newer environments, edge computing, for example. Everything is smart today, so there are all these smart cyber-physical systems. How do we influence or help with sort of getting those systems ready from the networking perspective? Serverless computing is sort of the next shift in computing as a service. And so some of the work that we will see that's already ongoing is helping support those kinds of environments. And I'll say that there are two sort of new things here that we should perhaps now focus on. One is data plane programmability, something that you heard a lot about from Chang just yesterday. And one aspect that I want to talk about is how do we sort of help bring this vision to reality of SDN using advances in data analytics. So that's really what I'm going to focus on. And so I'm not an expert on data analytics, but I'm going to give you a set of use cases that I think are interesting. And I'm also going to look back on the work that has already happened and using some of those examples, show you where I see some potential for good collaborative work to really move the technology forward. By the way, if people have questions, please feel free to raise them. I can take them as we go. And I guess there's a microphone or something to, yeah, okay. So networks typically don't evolve on their own. Networks are there to connect applications and services. And so we definitely have to look at what's happening in the world, right? So if you look at any number of these technology trends that are published by various groups, you'll see that there are things happening which we eventually have to support. So there's a lot going on in IoT today, robotics, smart cars and assisted transportation systems, augmented reality, virtual reality. There are a whole bunch of these examples that you can look at, and when you look at this, you realize that we are never going out of business. The networking research community is never going out of business because these are sort of the continual targets that we have in networking research. There are new workloads. And some of the emerging workloads I already mentioned. There's also sort of things that we haven't quite solved as much. I mean, even with all of the advances, I think providing predictability of performance, of availability, of cost, security, privacy, all of these things are still out there. How do you provide predictability at scale while there are a large number of diverse applications that are all mixing together and using this shared resource? And the fact that it's a shared resource causes a lot of these kinds of issues, and there's still plenty of work to be done here. And then the original goal of removing operational complexity, what's being called or touted as self-driving networking, is something that we're still not quite there yet. And I've mentioned a number of areas here. Some of you are working on these. Configuration management and verification. How do we sort of debug networks very quickly? How do we support hybrid environments? Because again, this is one of those very important aspects of practical deployment that always comes back to haunt us, is that not everything will be homogeneous. Not every piece of the network will be, will not have the same programmability, and you do have to deal with legacy. And again, many of you have worked in these areas already. So let me get to the sort of the focus of my talk, which I called smart programmable networks. Now, it's obvious to all of us that this has been called the golden age of data. We've been collecting lots and lots and lots of data. And there have been many advances recently in data analytics, machine learning, data mining. And there have been several successes in data-driven approaches to monitoring very complex systems. So the question here that I'm asking is, and I'm not the only one asking this, it's being discussed in different forums. Can you use some of these advances in making complex systems like networks better? And better in a number of different ways. I'll talk about some use cases. So the opportunity here is make programmable networks smarter to address some of the existing challenges. And as I was mentioning, that as we've gone through sort of this whole phase of research, we have encountered things that we didn't think about right at the beginning. And some of those problems still abound, and I'll give you examples of that. And I really enjoyed Jennifer Rexford's talk at SIGCOMM last year when she talked about the great successes with programming language research community and the networking community. And I think that having a similar kind of collaboration with the data scientists and machine learning and data analytics community may give us some answers to some really hard problems. So this is the opportunity. And boy, do we have data. We do have a lot of data. We've been collecting it for a long time. I'll talk a little bit about the aspects of the data that make it somewhat challenging. But if you think about it, network topology, device configurations, policy information, counters, performance metrics, I'm sure Chang would have talked yesterday about the ability to now measure everything. All the packets can be captured, all of the information kept, things that we couldn't do before. We had to work with sampling techniques and things like that. Today, you really can collect everything. And you can collect network and application protocol state. You can collect operational data. We've been logging trouble tickets, for example. Can we sort of do something with those kinds of data as well? You can figure out which applications, microservices communicate with each other and what are the communication patterns, can we leverage things like that. So we have a lot of data. Now what do we do with it? So it's a two-way street in the sense that you have you can use network data to make applications better. You can take applications data and make the networks perform much more efficiently. So I'll try and give you a few examples of both kinds. So some of the use cases, and there are plenty, this is not a complete list by any means. Some of the use cases that you may not have thought about. So one of the big problems in networking definitely is debugging and troubleshooting, right? There's a lot of data telling you that it's much, much harder to detect a network problem than to fix it. So you may spend a lot of time trying to figure out what's wrong, but once you've figured it out, then you can fix it very quickly. Some of these problems recur. These are usually logged in an operational network using trouble tickets. And can we mine that data? Can we use that data to make the next round of debugging much faster? Now, some of this kind of work is already going on. It's not sort of exclusive to networking, but I think these are the kinds of use cases that we should probably focus on. One of the challenges about middle boxes and having middle boxes or network functions in operational networks is that oftentimes you don't have a very good idea of what's happening inside the middle box. So there's a tremendous amount of work going on in middle box modeling. Now, if I had a lot of this data already being collected, can I build operational models of network functions using the data that I've been collecting? Can I predict faults before they will occur? Not an easy task at all, but I think we should probably try a little bit harder to see if SLO violations can be detected before they occur. Can we figure out sort of demand changes and re-provision our network as needed? There's a lot of work going on right now to try and improve application performance, particularly in the case of video. There have been some really good papers on this topic where you try to predict what bit rate you should be using, how would you compute some of the video parameters by looking at the data. And a few of the examples that I'll talk about relate to intent-based networking and trying to understand application structure. Okay, so we do have a lot of data, but there are quite a few challenges as well. So collecting is not very hard anymore. But the collection process oftentimes is quite ad hoc, and this is something that a lot of the data scientist community will also tell you, that the people who instrument or people who collect the data are often not the same people who are analyzing the data. So you may not have collected the right data. Now in the future, maybe we'll be able to collect everything that can be sort of collected, and then maybe you won't have the problem of missing information. But today that's definitely the case, where you don't have everything that you need because the people who are collecting and people who are using it are different. In terms of the diversity of the data, so one of the messages that I'd like to convey is that we need to take a look at the data holistically. So we have network data, we have application data, we have configurations, we have logs, but really what we should be trying and doing is doing cross-layer analytics. A lot of the work that we do today is sort of focused on specific layers. So let's look at TCP data to sort of make the throughput better or something like that. But if you had more information across the stack, maybe you'll be able to make some decisions that you couldn't do otherwise. Making the data actionable is still very hard. And a lot of it is the algorithms themselves are hard to develop. In network data and most of our infrastructure out there today is very dynamic. So things are changing very rapidly. So you need to have methods to do incremental analysis of large amounts of data. Again, not very easy. Replay and traceback capabilities are really important. Need to make sure that data is not leaking. So stuff that needs to be private and secure needs to be kept that way. And it's not often very clear if there's sort of leakage happening without you realizing it. And then complete data may not be available, as I mentioned before. So what are the inference techniques that we should be focusing on? There's plenty of work to be done in that area as well. So some of the things that make things challenging even more is that you often are collecting data about the same phenomenon, if you will, across the board. And what ends up happening is that they're stored not in a common schema. And so it's hard to sometimes correlate. And these are not sort of challenges just to the networking area, but in general. And you have a combination of structured and unstructured data. And this is, again, something that in the network space will continue to become more important. Some of the data is hidden or incomplete, or it may be erroneous because some sensor may be malfunction. So you need to be able to make sure that you are operating on correct data. Otherwise, you're going to have problems with the decisions you make. The programmable infrastructure is a big part of this thing because a lot of the times when you need to close the loop, so you've measured something, you've inferred something, and now you need to close the loop and actually take action. So the programmable infrastructure needs to be there. A lot of it is emerging. The deployments are not everywhere yet. And then, as I mentioned, hybrid and heterogeneous infrastructure needs to be also looked at. So one aspect that perhaps the networking community hasn't looked at as much and perhaps should start looking at is what is this overall data infrastructure that you need to have out there? So is there sort of a common framework within which you collect data, analyze data, make sure that you're able to sort of put them exactly where you need the decision to be made? And again, sort of sharing, aggregating, correlating across the stack is something that needs more attention. And when I think about sort of the infrastructure that we have, it's definitely distributed. It's cross-layer, cross-flow, cross sort of components of an application. And so keeping track of all of that and analyzing them fast is a challenge. So now I'm going to switch, and in the next few minutes that I have, I'm going to go over a few examples. So as I was preparing for this talk, I was thinking back to some of the work that has gone on and some of the work that I've been involved in. And I was trying to understand, where did we sort of, have to stop, or where we could not sort of progress further, and can some of these techniques help us? So I started with thinking about intent-based networking. Obviously, one of the sort of complexities in running a network is that we still tend to configure things at a very low level. And when you sort of configure things at low level, it's easy to make mistakes. And it's easy to sort of, have problems down the road that you couldn't detect. So intent-based networking is the name for this now, where you try and provide high-level abstractions of what the requirements are, and you have an intent compiler or something that takes those high-level intents and sort of converts them into actual low-level configurations, and this is done in an automatic way. So the humans basically operate at the high level, and the machines take over and do a lot of the configuration computations automatically. So if you think about some of these intents, and I made these up, and some of them are directly connected to networking, and some are just more infrastructure level intents. So think about an intent like this. All non-production cloud servers in a particular geographic region need to be switched off during non-peak hours. So this is something that an operator at some point in time will be able to specify, and the infrastructure will take care of it. But for the infrastructure to sort of make those right decisions, it needs to understand, which are the non-production servers, what are the non-peak hours. So somehow that information needs to sort of propagate through the system. Think about another intent. Authorized R&D employees should have access to company financial data. So this basically means that at the end of the configuration process, you should not have the ability for anybody outside this group to have access through either firewall rules or some other mechanisms to the servers that host this financial data. Another example, researchers should receive high-quality video, on the intranet. So you can just sort of start thinking about what it would take to actually make that happen. And then, there are intents that might conflict or might be underspecified. So if you have another intent which is related to energy, and say something like 20% of non-production servers are needed for slack capacity, so these cannot be switched off. So if you look at these high-level sort of descriptions of what you want to get done in the network, there is the potential for conflict. There's a potential for sort of things not being completely specified. And is there a way, for example, using question answering kinds of mechanisms, natural language parsing down the road? And there are already systems that are coming out that help with this kind of clarifying of intent. But let's just go on with this example a little bit more. So I already mentioned that intent-based networking looks something like this, where you specify a high-level intent, and then the control plane takes over and makes decisions about how to translate that intent down to configurations, and then through control APIs, you make sure that the infrastructure gets configured the right way. So the intent specification, there are many different kinds of specifications. One of the works that I was involved in used graph-based specification of intents. So you have groups that interact with each other, and you want to be able to specify what middle boxes they go through, what ports they can access, they can have the communication over, what might be the quality of service requirements, what are the chaining requirements, what are temporal constraints, what stateful behavior you want to be able to provide. So you have a bunch of these, and bunch of these intents are written separately and independently. And you have to be able to compose these policies into something still at a high level. You're still at a high level of abstraction. You still haven't put it down onto the infrastructure. But you want to be able to compose these policies in the correct and conflict-free way. And in some cases where you have quality of service requirements, you will need to be able to sort of, we have at least formulated it as an optimization problem, and then you need to be able to figure out where what controls have to be set in terms of rate limits and so on. And then once you've gotten the composed policy, you give it to a controller, which now can take the bindings, the low-level deployment bindings, server IP addresses or MAC addresses, and sort of figure out how to actually deploy it. So you have the infrastructure at the bottom. So this is the rough sort of idea. Now the big question is, how do you get some of the information about who's in a group, what applications are running, what are the middle boxes actually doing, what's the application structure and dependencies, the topology, traffic, and the deployment bindings. All of these things somehow have to be fed in to this whole process of taking a high-level intent down to the infrastructure. So let's sort of go on a little bit longer with some of these, some of this process. And think about sort of taking the example that I had at the beginning about some high-level intents. And you can sort of draw little pictures like this, like we did in the PGA project, where now you have, say, these 3 high-level intents that have been specified independently. And you realize that, just taking a look at it, and these are only 3 and they're relatively simple, that it's quite underspecified. So the first intent, which says, on-prem or campus environments can communicate with the cloud environments through a firewall. Now the question is, where are the R&D folks, attached to? Are they on-prem? What does authorized mean? And you can, if you look at it carefully, this doesn't preclude the possibility of non-researchers being able to or researchers being able to access the financial service, which may not have been part of the intent. So what you need is, what are the kinds of service, what's the service status, production, non-production, sales, R&D, employees. All of this information, by the way, exists. It's there in the infrastructure somewhere, stored in different places. And the approach that we took was that if you had this information, then you could basically take the original intents and compose them in a way that removes the conflict. So one possible composition, and I'm not going through the details here, you can look at some of the references that I'm putting in the slides. And this is one possible composition. Now, one question might be, does the firewall go before the load balancer, or the load balancer goes before the firewall? So you need additional information about these kinds of correctness principles to be able to put them together. So for intent-based policies, you're already depending on a lot of infrastructure data, which is out of band, right? It's being stored, in a separate place. It may not be complete. And so the question is, if you don't have all of this complete information, how would you get it? And is there a sort of a potential for analyzing these hidden relationships and inferring these hidden relationships to help your composition? So taking the same example forward, now you have this composed policy, and now you want to be able to get it deployed. So you have the infrastructure, and now you have to build the configurations. Now remember that we had a few other intents related to, how do we provision the servers? Which ones should be in production? Which ones should be in sort of standby mode? And so you need to have these Slack servers identified. You have the server energy optimizer module, which is coming up with the exact set of servers to switch off. And then back where you have the trying to make sure that the network energy is also optimized, you have a third module, which is taking into sort of account the topology, the traffic matrix, the power models, routing restrictions, and so on. This is sort of part of the work that we did a while ago called Elastic Tree. And it sort of gives out a bunch of switches and links that you can turn off. Now, clearly, all of these three modules are interconnected. And they're interconnected by the fact that the network energy optimizer will be able to do a better job if it had the server energy optimizer consolidate or sort of make sure that the servers that were being turned off, there were more opportunities to turn off network switches because these servers were in the same cluster, for example. So there is this sort of interaction, but remember, one of our goals was to have this building independent software modules in implementing different SDN apps. So the problem here is that if you needed to provide this global optimization capability without really having these modules being dependent on each other or even sharing too much information with each other, we worked on different schemes, and there have been many different pieces of work on this, including the Statesman work from Microsoft. And the idea that we came up with a few years ago was, rather than having a lot of information between each of these modules could basically share their resource allocation using whatever internal algorithms they might have, and share these resource proposals across these different groups or different modules, and then there would be a resource conflict resolution module that would then vote on each of these proposals and then renegotiate the right proposal that did the global good. Now, for things like this, and I'm going a little bit fast because now I'm running out of time, one of the difficulties is how would you know what each of the modules is trying to achieve? Again, there's a great opportunity for learning about these different modules just by analyzing the proposals that they produce. And through that, you can come up with a sort of a global optimized resource provisioning, which individually you couldn't have or without having a lot of interaction between them. So at last year's, so this is my last example, which is on optimizing the data plane using these high-level pieces of information that you wouldn't have normally used. So with programmable switches, today you can take high-level P4 programs which operate on a large number of different tables, and you can put these together in different stages, connecting them in an optimized fashion. And if you had information about the intents that I was talking about earlier, where you can see what specific groups are interacting with each other, what features do they need, you realize very quickly, if you look at the bottom graph of the network, that there is really no support group in this particular example, which means that certain features do not really have to be implemented. And this is a paper that we presented at SOSR last year. And the idea is that you can take the knowledge of these high-level application requirements, and you can generate much more accurate table dependencies, which then you can use to remove features that you don't need. And so the original stage that might have required, original design would have required 10 stages, you can optimize very quickly in this small example to 6 stages, because now you have information about which are the communicating entities, what features do they need, what features are exclusive, and so you can pack them together in a much more optimized fashion. With 1 minute to go, let me summarize. So there is an emerging opportunity here with cross-layer data analytics. I've given you a sort of a glimpse of a few examples. The truth is that the goals of automation and being able to have modular features and applications work very nicely in the network environment has proved to be more challenging than we thought. And so the question is, now can we couple sort of the advances that are happening in the data analytics and machine learning and reconfigurable hardware and other areas? Can we sort of leverage these in a way that really sort of gets us to our original goal and vision? And some of the practical considerations here, because as we go through this process, we realize some of the things that we didn't think of right off the bat. That you can't really assume certain things about network deployments. Oftentimes we are going after killer applications, but really we should be going after pain points. And killer applications may emerge, may sort of change over time. You're really not sure. I think history definitely shows us that. The simplest solutions typically always win. So if you come up with a complex solution, it will be probably hard to deploy. And then it's a question of how do you handle legacy infrastructure? You often cannot do forklift upgrades in every scenario. And with that, I think I'm done. And if you have questions, I'd be happy to take them. But I think we only have a minute or so for questions. Thank you.
I think we should take a few questions. Let's first thank Sujata for the great keynote.